So this is problem 16, section 1.6. You're given a piecewise defined function defined over 4 pieces. Sketch the graph of this function and find the following limits. Well, in this particular case, you don't need to graph it because you can simply find the answers from the left or from the right using purely the algebra here. Okay? When x approaches negative 5 from the left, I'm looking at negative 5 here. When x is to the left of negative 5, left means less than. So that's the rule, that's the condition we are looking at. So the rule is 13. It's a constant function, 13, to the left of negative 5. So limit is constant, so there is nothing to plug x in. So that's x. When x approaches negative 5 from the right, to the right of negative 5 are these options, but we are near negative 5. So near negative 5 is this one. When x is approaching negative 5 from the right, x is greater or equals negative 5, but near enough. So I'm looking at this area. So that's the function, that's the rule. So I'm now going to plug in negative 5 into this rule. So it is a negative 5 plus 8. I hope it's clear. Negative of the negative 5 plus 8. Now I don't know whether they agree. What do we think? 8 plus 5, 13. They will agree, so it is 13. X approaching 7 from the negative side. 7. So, equal 7, the value is negative 1. But to left of 7, that's the rule. So I'm going to plug in 7 in this rule. Negative 7 plus 8. We know that's a 1. Positive 1. X approaches 7 from the right, so greater than 7. So that's this case. That's an 8. Okay? So I hope this is clear. From the left means x is less than 7. That's why we looked at this piece. Right means x is greater than 7. So we are looking at this piece. Now, are they equal? So that's a plus 1. This is 8. They are not equal. So limit does not exist. Okay? Let's submit and check. We are fine. Next. This box x denotes the greatest integer that is less equals x. Greatest integer, we covered this in class. Greatest integer is the step function. Okay? Step function. So what does that mean? They are using bracket, so I'll use bracket of 3.5 is what? Greatest integer less or equal x. So less than 3.5 or equal to 3, but you want an integer, so 3.3, that is it. Greatest integer less than or equal to 4.1, it is a 4. So what's happening? For m is any integer. What is the greatest integer less equals 4? It is 4. If m is an integer, find left hand limit versus right hand limit. And what can you say about the limit? Well, suppose my number m were 4. Value at 4 is 4. The value at 4.1 is 4. Value at 3.9 is 3. Okay? Now my function f is not simply the greatest integer function. It is x minus greatest integer. F of x equals x minus greatest integer x. So suppose m were 4. Well, what is f at m? It is 4 minus box 4, which is 4 minus 4, that is 0. Okay, m is 4. Okay, I've just plugged in. What is to the right of m? So f of 4.1. Well, x is 4.1 minus box 4.1. What do I get? 4.1 minus 4, that is 0.1. F at 4.01 is 4.01 minus box 4.01, that is 4.01 minus 4, that is 0.01. So you see, as my x approaches 4 from the right, I'm getting closer and closer to 0. Okay, so as my x approaches m from the right, my limit is going to be 0. Okay, I'm getting smaller and smaller basically. What about from the left? F of 3.9. It is 3.9 minus box 3.9. Well, 3.9 minus 3 box of 3.9 is 3. F of 3.9. Oh, by the way, I didn't complete it, right? It is 0.9. F of 3.99 is 3.99 minus box 3.99. That is 3.99 minus 3. That is 0.99. Looks like I'm getting closer and closer to 1. From the left it is 1, from the right it is 0. So limit does not exist. Okay, I think this video is getting a bit long. I'll start on the next video. Until then.